continuing our discussion on resolution of vectors. The splitting of vector into two or more vectors is called a resolution of vector, and the vectors into which it is splitted are called component vectors. For example, we can consider one vector. Let this is vector A. This vector A can be split into two or three components like this. It can be split into two or three components. One vector is along the x-axis. This is a vector along the x-axis. Another vector along the y-axis. And we can split this and this vector in z-axis also. Okay, so we can split vector into three components, one along the x-axis, one along the y-axis and another one along the z-axis. This vector along the x-axis can be written as vector Ax. Okay, and this vector along the y-axis is vector Ay. This one along the z-axis is vector Az. So vector A can be split into three components, or we can split vector into two components also. What are they? Ax and Ay. In plane we can consider only two components, Ax and then Ay. In space, motion space or three-dimensional motion, we have to consider all the three components along the x-axis, along the y-axis and z-axis. So anyway, any vector can be split into two or three components. Here vector A can be split into three components, vector Ax, vector Ay and vector Az. So we can write one form, vector A is equal to vector Ax plus vector Ay plus vector Az. That is in three dimension. In two dimension we can write vector A is equal to vector Ax plus vector Ay. So this is in three dimension, 3D. In two dimension, this one in two dimension. Yeah, so any vector can be resolved into two or three components like this, vector A equal to vector Ax plus vector Ay plus vector Az, or in two dimensional vector A equal to vector Ax plus vector Ay. So anyway, any vector can be resolved into two components or three components like this. Here we are specifying our discussion on two dimensional alone, because we are discussing the motion in a plane, no? So we are specifying all our discussions on two dimension alone. Now this is one resolved form. Okay, this is the first resolved form. Similarly, vector Ax means it is a vector along x direction. So we know that vector Ax can be written as, any vector can be written as Ax into I cap, no? What is its magnitude? Vector Ax magnitude is Ax and it is along x direction, therefore it can be represented by I cap. Vector Ay can be written as, its magnitude is Ay into j cap. So another resolved form of vector A can be written as vector A equal to Ax I cap plus Ay j cap. I cap and j cap are unit vectors. So a vector can be represented in another resolved form as vector A equal to Ax I cap plus Ay j cap. Okay, so these are the two resolved form of a vector. Any vector can be represented in resolved form as vector A equal to vector Ax plus vector Ay. Another form is Ax I cap plus Ay j cap. Now, what is this Ax? How will you find out this Ax? We know that cos theta. If you consider this right angle triangle, cos theta is equal to adjacent side, which is Ax, divided by hypotenuse. What is the hypotenuse? A. Its magnitude is A. Okay, so cos theta is equal to Ax divided by A, and Ax is equal to A cos theta. Similarly, if you take sin theta, what is sin theta? Sin theta is equal to opposite side. Opposite side means these two are parallel. So opposite side is Ay divided by hypotenuse is A. So what is the value of Ay? Ay equal to A sin theta. Okay, so the component Ax can be written as A cos theta and Ay equal to A sin theta. So any vector, vector A is equal to, first form is vector Ax plus vector Ay, and second form is Ax I cap plus Ay j cap. And what is the value of Ax? Ax is equal to A cos theta and Ay equal to A sin theta. Theta is the angle between the original vector, vector A, and the x component. Okay, this angle is theta. Similarly, vector B, how will you represent vector B in resolved form? Vector B, example we can write, vector B in resolved form can be written as, in 2 dimension, vector B can be resolved as vector B equal to, what is the first form? Vector B can be written as vector Bx plus vector By. Okay, or we can write vector B equals another form, vector Bs, its magnitude is Bx, isn't it? And it can be represented by I cap because along the x direction, plus what is By? Vector By is By into j cap. These are the 2 different forms. Clear, children? Next property of vectors is product of vectors. There are 2 types of product of vectors. Number 1, scalar product or dot product, and number 2, vector product or cross product. First we can study the dot product or scalar product. Consider 2 vectors, vector A and vector B, separated by an angle theta. Now the dot product or scalar product between the 2 vectors is given by vector A dot vector B, that is called a dot product. Vector A dot vector B equals AB cos theta. This is called a dot product. If A and B are the 2 vectors separated by an angle theta, then the dot product of 2 vectors is vector A dot B equals AB cos theta. Why it is called a scalar product? Because A is a vector quantity, B is a vector quantity, but the obtained product is a scalar. Okay, hence it is called a scalar product. Some examples of scalar product of vectors are, we have work is equal to F dot S, force dot displacement. F dot S is work or Fs cos theta, where theta is the angle between force and displacement. That is, we know that force is a vector quantity, displacement is a vector quantity, but work is a scalar quantity. Okay, so work is given by F dot S. Another example is given by power. Power equal to F dot V, force dot velocity, that is called the power. Or F dot V equal to Fv cos theta. Here also theta is the angle between force and velocity. So force is a vector, velocity is a vector quantity, but the product, dot product or scalar product, F dot V, which is power, which is a scalar quantity. So these are the main 2 examples for scalar product of vectors. Now we can study the properties of scalar product. First property is, we know that vector A dot vector B equal to AB cos theta. AB cos theta can be written as BA cos theta also, no? So BA cos theta is actually B dot A. So there is no change in AB cos theta and BA cos theta. That means A dot B and B dot A are equal. What is that property called? That is called commutative property. Okay, so dot product of the 2 vectors is commutative in nature. Then second property, if there are 3 vectors, vector A, vector B and vector C, then we can write vector A dot B plus C, vector B plus vector C equal to A dot B plus A dot C, A dot B plus A dot C. And what is that property called? That property is called a distributive property. That means dot product of the 2 vectors is distributive. So the dot product of the 2 vectors satisfy commutative property and it also satisfy distributive property. Okay, children? Then next one, if vector A and vector B are perpendicular to each other, like this, if vector A and vector B are perpendicular, that means what is the value of theta? Perpendicular means theta is 90 degree. Okay, so A dot B equal to, we can write AB cos 90. What is the value of cos 90? 0. Okay, so A dot B equal to 0, or we can write it is a 0 vector, right? So if 2 vectors are perpendicular to each other, vector A dot vector B equal to 0. Now if 2 vectors are parallel to each other, vector A and vector B are parallel to each other, that means like this, this is vector A and same is the direction of vector B. These are called parallel vectors. What is the angle between them? Angle theta is equal to 0, right? So that is A dot B equal to AB cos 0. What is the value of cos 0? 1. So A dot B equal to AB. Now if a vector A and vector B are anti-parallel to each other, anti-parallel means like this. This is the direction of vector A, opposite is the direction of vector B. These are called anti-parallel, which are in the opposite direction. What is the angle between them? Angle between them is 180 degree. Okay, if the two vectors are anti-parallel means the angle between them is 180 degree. So theta is equal to 180 degree. Therefore we can write A dot B equal to AB cos 180. What is the value of cos 180? Minus 1. So its answer is minus AB. Okay. Next property, we know that vector A can be represented in resolved form as Ax I cap plus Ay j cap, and vector B in resolved form can be represented as Bx I cap plus By j cap. This is in 2 dimension. So vector A dot vector B can be written as, you can substitute Ax I cap plus Ay j cap dot Bx I cap plus By j cap. Now we can multiply equal to Ax Bx. Okay, Ax Bx into I dot I plus similarly Ax By into I dot J plus Ay Bx into J dot I plus Ay By into J dot J. Okay children, so Ax Bx into I dot I plus Ax By into I dot J plus Ay Bx into J dot I plus Ay By into J dot J. Now what is this I dot I? I dot I, we know that I, J, K, these are unit vectors. So what is its magnitude? Magnitude is equal to 1. So I dot I means the magnitude of I is 1. The magnitude of is 1. So 1 into 1. What is the angle between I and I? Both are along the x direction, no? I and I are along the x direction. So what is the angle between them? 0. So cos 0. So cos 0 is 1. So I dot I equal to 1. J dot J equal to K dot K is equal to 1. So I dot I equal to 1, J dot J equal to 1. Remaining, what is I dot J? I dot J means I along the x axis, J along the y axis. So I dot I, magnitude is 1 into 1. I dot J, what is the angle between them? I along the x axis and J along the y axis, angle is 90 degree. So it is cos 90. And what is cos 90? Cos 90 is equal to 0. Similarly, J dot I, what is J dot I? That is also 1 into cos 90, that is 0. I dot K, 0. K dot I, 0. J dot K, that is all 0. Okay, so similar unit vectors I dot I, J dot J, K dot K is equal to 1 and all other dot product is equal to 0. Now we can write what is vector A dot vector B. How will you write that? Is equal to I dot I equal to 1, J dot J equal to 1 and remain equal to 0. So we can write Ax Bx plus Ay By. Okay, so A vector A dot vector B can be written as Ax Bx plus Ay By. Is there any I and J in the product or I and J in this value? No. That means vector A dot vector B is a pure scalar quantity. That means there is no I value or J value or K value here. That means A dot B is a pure scalar quantity. So in this method we can prove that vector A dot vector B is a scalar. So these are the properties of dot product or scalar product. Now second one is vector product or cross product. Consider two vectors, vector A and vector B, separated by an angle theta. Now the cross product or vector product of these two vectors is given by vector A cross vector B equal to AB sin theta in the unit vector n. N cap is the unit vector. N cap is the unit vector directed in a direction perpendicular to the plane containing vector A and vector B. So what does it mean? AB sin theta n cap means A is a vector, B is a vector, and its product is also a vector quantity. Hence the name vector product. Okay children? Now how do you find out the direction of this n cap? The direction of n cap is given by a right hand thumb rule. According to right hand thumb rule, if you curl the fingers of your right hand in the direction of rotation from A to B, we have to find out A cross B. So from A to B, then the thumb always proceeds or points in the direction of A cross B or n cap. So the direction of n cap or A cross B is given by right hand thumb rule. That means like this, from A to B. So forefinger points in the direction from A to B, thumb is in the outward direction. So thumb is perpendicular to the plane of the paper in the outward direction. So this represents the direction of A cross B or n cap. So direction of n cap or direction of A cross B is given by which rule? Right hand thumb rule. The direction of A cross B is given by right hand thumb rule. According to this rule, if you curl the fingers of your right hand in the direction of rotation from A to B, then the thumb points in the direction of A cross B. So using this right hand thumb rule, we can find out the product or vector product of two vectors. Now what are the properties of vector product? First property, A cross B, we know that A cross B is equal to AB sin theta into n cap. A cross B is AB sin theta into n cap. N cap represents the direction. So what is this direction from A cross B or n cap? A to B. Rotate or curl the forefingers in the direction from A to B. So in which direction thumb moves? Thumb is in the outward direction. So this is the direction of the A cross B. Clear? Now what is B cross A? B cross A is BA sin theta into, we can represent n dash cap. What is the direction of n dash cap? B to A, from B to A. So in which direction the thumb moves? It is into the plane of the paper. Is it clear children? A to B means the forefingers moves like this, A to B. So the thumb points in the outward direction, perpendicular upward to the plane of A and B. Then B cross A means BA sin theta into its direction is, what is its direction? From B to A means like this. So into the plane of the paper. So A cross B and B cross A, magnitude wise we can say that they are equal. AB sin theta and BA sin theta are equal. But what about the direction? One direction is upward and other direction is downward. That means we can say that A cross B and B cross A are not equal. A cross B not equal to B cross A. That means the vector product of two vectors, the vector product of two vectors is not commutative. Vector product of two vectors is not commutative. Okay. Now second property, if there are three vectors, vector A, vector B and vector C, we can write vector A cross B plus C. Vector A cross B plus C can be written as A cross B plus A cross C. What is its property called? This is called a distributive property. That means vector product satisfies which property? Distributive property. If two vectors, vector A and vector B, are perpendicular to each other, that means what is the angle between them? Theta is 90 degree. Now we can write vector A cross B is equal to AB sin 90 into n cap. So sin 90 is 1, therefore it can be written as AB n cap. Now next property, if two vectors are parallel or anti-parallel, now theta is equal to 0 degree, anti-parallel means theta is equal to 180 degree, isn't it? So now A cross B can be written as AB sin 0 or 180, sin 0 or 180 into n cap. What is sin 0 or sin 180? Sin 0, 0, sin 180 is also 0. So what is A cross B? A cross B is equal to 0. So if two vectors are parallel or anti-parallel, its cross product is equal to 0. Now fifth property, vector A can be represented in resolved form as AXI cap plus AYJ cap plus AZK cap. Similarly, vector B in resolved form as bxi cap plus byj cap plus bz k cap. Now, how will you find out A cross B? So, A cross B can be written as A cross B is equal to, we have to find this A cross B by another method, that is called a determinant. This is called, these two lines are called a determinant. First you draw the two lines, then in between you have to write first step I, j, k. Okay, so this is the method, unit vector I, unit vector j, unit vector k. Next A, first vector is A, no? So here we have to write the components Ax, here Ay, here Az. Second vector is B, so here we have to write the components Bx, By and Bz. Clear? So in order to find out the product in resolved form of vector A is given, where for resolved form of vector B is also known, and A cross B is equal to draw the determinant I, j, k first line, then Ax, Ay, Az, then Bx, By, Bz. Next, how will you multiply this? That is I into, this is the method, I into, leave the row and the corresponding column. Okay, I into, then you have to multiply like this. So just leave this row and the column and write Ay, Bz minus Az, Bx. This is the step. Ay, Bz minus Az, By. Okay, Ay, Bz minus Az, By. Then second term is minus j cap into, again leave the row and the corresponding column, this one and this column, then multiply towards the right. Ax, Bz minus Az, Bx. Okay, Ax, Bz minus Az, Bx. Ax, Bz minus Ax, Bz minus Az, Bx. That is the next term, second term. Then third one is plus k cap into, again leave the row and the column, again you have to multiply towards the right first. Ax, By. Ax, By minus Ay, Bx. Ay, Bx. Clear? So this is the method of finding the cross product of the two vector in resolved form. Okay, so if you find the product, the final product having I cap, j cap and k cap, isn't it? After multiplication and after the final value has I cap, j cap and k cap. That means the cross product of two vectors, or the vector product of two vector is purely a vector. Okay, because it has the product having I cap, j cap and k cap. That shows that cross product of two vectors is a vector. Okay, children. Now we can do one question relating dot product. If a force vector F equal to 3i plus 4j minus 5k acts on a body which produces a displacement, vector S is equal to 5i plus 4j plus 3k. Find the work done. We have work done is equal to F dot S. Work done is equal to force dot displacement. Okay. Now substitute the force is 3i cap plus 4j minus 5 cap dot displacement is 5i cap plus 4j cap plus 3k cap. Now we can multiply 3i cap dot 5i cap. What is I dot I? We know that I dot I, j dot j, k dot k equal to 1, and the dot product of dissimilar unit vector is equal to 0, that you know. So 3i cap dot 5i cap. 3i cap dot 5i cap is 15. I dot I is 1, no? Then remaining 3i cap dot 4j cap, that is equal to 0. Similarly 3i cap dot 3k cap, that is also 0. Clear? Now next term 4j cap dot 5i cap, 0. 4ij cap dot 4j cap, what is that? Plus 16. Remaining becomes 0. Similarly minus 5k cap dot 3k cap, that is minus 50. And all other remaining values becomes 0. So once more 3i cap dot 5i cap, that is 15. Then 4j cap dot 4j cap, that is 4 into 4 16, minus 5k cap dot 3k cap, that is equal to minus 50. So what is the answer? The answer is equal to 16 joule. Okay children, so answer is 16 joule. So this is the method of finding dot product of two vectors. Find the vector product of vector A equal to 3i minus 4j plus 5k and vector B equal to minus 2i plus j minus 3k. So we have to find out A cross B. So we know that A cross B. How will you find out A cross B? Using determinant. First I, j, k, unit vectors I, j and k. Then below that A, first vector is A, we have to write the components of A. Here 3, here minus 4, here component or the magnitude of k is 5. Now second vector is B, here minus 2, here 1, here minus 3. Okay, is equal to, then we have to multiply unit vector I into, leave the row and the column, then minus 4 into minus 3, 12, minus 5 into 1, 5. Then second term is negative, minus j into, again leave the row and the column, multiply like this, 3 into minus 3, minus 9, minus, okay, 5 into minus 2, that is, what is that, minus 10. Then third term is k cap into like this, again multiply towards right, 3 into 1, 3, minus 4 into minus 2, 8. So it is 8. Clear children? So I once more, I into minus 4 into minus 3, 12, 5 into 1, 5. Second term negative, minus j into, leave the row and the column, minus 9, minus 10. Then k into plus k into 3 into 1, 3 minus 8. Okay. So it is equal to, here it becomes 7i, I cap, here minus j cap, here minus 5k cap. So final vector, final product A cross B containing I, j and k. Okay, so this is the method of finding vector product of two vectors.